I'm Mary Beth Borley. I will be your instructor this semester for Stat 251 at Doña Ana Community College. The textbook we're using this year is Essential of Statistics, the 6th edition by Mario F. Triola. We'll be using my Stat Lab. There's a lot of resources in there. I hope you've been able to get onto my Stat Lab and investigate everything that's available to you. All right, let's get started with our chapter. Chapter 1 is an introduction to statistics, and in this chapter we will be covering statistical and critical thinking, types of data, and collecting sample data. Let's get started with statistical and critical thinking. The process involved in any statistical study consists of prepare, analyze, and conclude. When we are preparing to conduct a statistical study, we want to consider the context of the data, the source of the data, and the sampling method used to collect those data. The context of the statistical study can be thought of as the circumstances that form our original question that we're interested in. The source of the data simply addresses from what source we will collect our data. The sampling method will address how we will collect our data. And critical thinking is an important part of any statistical study or analysis. Critical thinking can be described as the suspension of judgment. Let's review some basic definitions we will use throughout this semester. The first term is the term data. The definition of data is it's a collection of observations such as measurements, gender, or survey responses. A single data value is called a datum. So your age would be a datum value. The ages of all of the students in this course would be the plural, data. Because the word data is plural, it is correct to say the data are instead of the data is. Some examples of data include age, height, clicks on a website, income, preferred ice cream, flavors, or the cost of a specific product. Data themselves are fairly useless. But when these data are interpreted and processed to determine its true meaning, they become useful and then can be named as information. Statistics is the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on the data themselves. Statistics provide tools for describing variability in the data and for making informed decisions based on the data collected. For centuries, people have collected and studied statistics on many things: trees, starfish, other people, stars in the skies, rocks on the ground, words. Statistics can be applied to almost anything that can be counted. The definition of a population is the complete collection of all measurements or data that are being considered. Typically, a population is the complete collection of data that we would like to make inferences about. The word inference means to draw a conclusion based on known facts or evidence. It can be described as an educated guess based on observations. So if I see that my granddaughter Gemma has crumbs on her lap and chocolate smeared around her mouth, I can infer that she has been eating some of the chocolate chip cookies that I have made earlier in the day. Census is the collection of data from every member of a population, and a sample is a subset or a subcollection of members selected from a population. It is often difficult or impossible to collect data on every member of a population, and so we can use a sample of the population to make an educated guess or an inference about that larger population. For example, if you want to compare the heat levels of different varieties of hatch green chilies, it would be impossible to measure all of the heat levels of every chili grown in the Hatch Valley. But you could collect samples of Big Jims, Joe Parkers, and Sandias and measure the heat levels of the chilies from that sample. Consider this example. In the journal article, Residential Carbon Monoxide Detector Failure Rates in the United States, it was stated that there are 38 million carbon monoxide detectors installed in the U.S. When 30 of those carbon monoxide detectors were selected randomly and tested, it was found that 12 of the 30 failed to provide an alarm in a hazardous carbon monoxide condition. In this example, our population would be the 38 million carbon monoxide detectors installed in the United States, and our sample would be the 30 carbon monoxide detectors that were selected and tested. The objective of this study is to use the sample data to determine if these detectors alert the consumer properly when hazardous conditions exist. In other words, is there any evidence that they are doing their intended job? So when we want to do a statistical study, the first step is to prepare. We can do this by determining the context of our study. In other words, what will our data represent and what is the goal of our study? If we consider our example of varieties of Hatch green chili, we may state that our data will represent the heat levels of those chilies, and our goal is to determine if there is a difference in heat levels among the three varieties. One source of data would be to take samples of each variety from various farmers' crops in Hatch, New Mexico. And in order to keep our study as unbiased as possible, our sampling method would attempt to take random samples from each farmer's yield. We could then analyze our data by graphing the data, summarizing the data by using statistics such as average heat level and the standard deviation in the heat level. And then we can apply statistical methods to our data to obtain results. And finally, we can use those data to draw a conclusion about the heat level of our three varieties. For example, we may determine that Sandias have the highest average heat level than either Big Jims or Joe Parkers. Let's consider another example. This table includes the number of registered pleasure votes in Florida in the tens of thousands, and it also includes the number of manatee fatalities from encounters with pleasure boats. The data were collected over several years. So the goal of this study is to determine if there is a relationship between the number of boats and the number of manatee fatalities from those boats. We could say that our hypothesis might be, as the number of boats increases, the number of manatee deaths also increase. The second step in our preparation of a statistical study is to consider the source of our data. As it turns out, the data in this table are from the Florida Department of Highway Safety and Motor Vehicles and from the Florida Marine Research Institute. Both of these institutions seem to be credible, and so we will assume that neither institution has any reason to obtain results that might show them in a favorable light. The data were obtained from official government records, and so we can conclude that the data are reliable and the sampling method is likely to be sound. When we consider the source of our data, we also want to consider the sampling method used to collect those data. One type of sampling method commonly used is the voluntary response sample. These samples are collected when the researcher puts out a request for members of a population to join the sample, and people decide whether or not they're going to be in the sample. Examples of these types of samples would be when a TV show asks his viewer to visit his website and respond to an online poll. YouTube asks you to respond to a short survey before you watch a video. Or a polling agency calls voters and asks them questions about a certain candidate. The following types of polls are common examples of voluntary samples. By their very nature, all are seriously flawed because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. Let's consider this example of a voluntary response sample. Nightline asked viewers to call in with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions. 67% of the 186,000 respondents said that the United Nations should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed. Of those respondents, about 38% wanted the United Nations to move out of the United States. The bias in the Nightline poll comes from the possibility that regular viewers of the television show may have a specific political perspective and may feel more inclined to call in to share their opinions. The two polls produced dramatically different results. Even though the Nightline poll involved 186,000 volunteer respondents, the much smaller poll of 500 randomly selected respondents is much more likely to provide far better results because of the superior sampling method used. Now that we've prepared our data and determined the goal of our study, we can begin to analyze our data. We can analyze our data with an appropriate graph of the data as well as an exploration of the data. We will discuss different types of graphs that we might use in the next chapter. Some of the graphs will include frequency distributions, histograms, scatter plots, correlations, and regressions. We will also want to complete a good and thorough statistical analysis. In this course, we will have access to tools that will help us develop our statistical analysis without requiring strong computational skills. The last step of our statistical analysis process is to draw a conclusion. It is important to understand the difference between statistical significance and practical significance. Statistical significance helps us to quantify whether our results are most likely due to chance or due to some other factor of interest. So, for example, if we take a random sample of 100 births and 98 of those births were girls, we would say that this is statistically significant because such an extreme outcome is not likely to result from random chance. This would be a rare occurrence, and we might suspect that there is some other factor that caused these results. However, if only 49 of the 100 births were girls, we would say this is not statistically significant because that outcome is more likely to occur since we know that there is almost a 50-50 chance of having a boy or a girl. Practical significance relates to whether the results from a statistical study are useful in real life. It is a way to address some of the limitations with traditional testing and answers the question, do your results have real-life application and meaning? For example, let's suppose a company is developing a weight loss program. And to study their weight loss program, they recruit 1,000 people for a randomized experiment. And they find that after 6 months, the average weight loss is about 1 pound. And this loss is determined to be statistically significant. Well, the company developing the program may conclude that most people would not be interested in a weight loss program if it resulted in only a 1 pound loss after 6 months. and they would want to decide that this has no practical significance and would consider a different option. Let's consider another example. ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having the baby with the gender that they desired. Let's suppose that the product was tested on 10,000 couples who wanted to have baby girls, and the results consisted of 5,200 baby girls born in the 10,000 births. This result is statistically significant because the likelihood of it happening due to chance alone is about 0.003%. So chance doesn't seem like a feasible explanation due to the results. So in the absence of any evidence of its effectiveness, the product was banned by the Food and Drug Administration as gross deception to the consumer. The 52% rate of girls is statistically significant. However, it lacks practical significance because a 52% chance of having a girl using this product is only slightly above the 50-50 chance. Couples would not want to spend the time and money to increase the likelihood of a girl from 50% to 52%. And it's interesting to note that in reality, the likelihood of having a baby girl is about 48.8%. Let's examine some potential hazards you may encounter when analyzing your data. First of all, you want to avoid misleading conclusions. When forming a conclusion based on a statistical analysis, we want to make statements that are clear even to those who have no understanding of statistics and its terminology. We also want to avoid making statements that are not supported by the statistical analysis. When collecting data from people, it is better to take measurements yourself instead of asking subjects to report results. If you ask a person what he or she weighs, you are likely to get a number that is far closer to their desired weight and not their actual weight. In order to have the most accurate data, it would be best to weigh the members of your sample rather than to ask them. And finally, avoid loaded questions. If survey results are not worded carefully, the results of a study can be misleading. A loaded question is a trick question, which presupposes at least one unverified assumption that the person being questioned is likely to disagree with. An example of a loaded question is, do you plan to vote for the candidate Smith even though she is an incompetent candidate? Some additional pitfalls we want to avoid include the order of the questions. Sometimes survey questions are unintentionally loaded by the order of the items being considered. Surveys can also be intentionally worded in order to elicit a desired response. For example, a poll conducted in Germany asked the following two questions and received two different results. The first question asked, would you say traffic contributes more or less to air pollution than industry? And 45% of the respondents to that question blamed traffic for air pollution, whereas 27% blamed industry. The second question that was asked was, would you say that industry contributes more or less to air pollution than traffic? In this question, 24% blamed traffic, while 57% blamed industry. Another pitfall is a non-response. A non-response occurs when someone either refuses to respond or is unavailable. This is important because people who refuse to respond are likely to be very different than those who do respond. And their refusal to respond demonstrates that their views of the world around them is different. Percentages. Sometimes studies will cite misleading percentages. Note that 100% of some quantity is all of it. But if there is a reference made to a percentage that exceeds 100%, such references are often not justified. For example, in an ad for the club, which is an anti-theft theft device used to discourage car thefts, it was stated that the club reduces your odds of car theft by 400%. But if you think about it, if the club was successful in eliminating all car thefts, then it would reduce the odds of car theft by 100%. In other words, all of it. So the 400% claim is misleading.